So what we're going to do, so we've entered our two lists we're going to create a box plot and we've got our two lists. So to go, and it's said there, so we created these two lists and we're going to just first do the box plot for class A. So once you've got your lists in, you click home and then we go to the data and stats page, just like we normally do, and we click class A and we're going to go menu and plot type and box plot. So once you do that, this is why it's a good way to see if there is an outlier. So we should actually do the test for it, but we can see there is one. Okay, so if you have a look there, so outlier is 3. Now, that whisker, can you see, is on 21. So the next little value, so you've got to make sure that you have that whisker. Then you can see the Q1 and the median, the Q3, and there's no upper outlier, so the whisker's going to the largest, which is 43. So often they will ask you to prove why 3 is an outlier. So if you go to do that, what you're going to do is you're going to go into your calculation. So you just do a normal calculation page. So 3 was a lower fence outlier. So you have to do Q1, which was 21.5 minus 1.5 times the interquartile range, which was, I can't remember what was Q3, 32. Okay, so it's 32 minus 21.5. So that's the rule for the lower fence. So if I click enter, anything below 5.75 is an outlier. So you would be writing, because the lower fence is 5.75, so because the number 3 was lower than that number, 5.75, it is an outlier. And then you might get asked to prove why there is no upper outliers. So you would do the same thing, but obviously it's Q3 plus. So Q3 is 32 plus 1.5 times the interquartile range, okay? So anything above 47.75 was to be an upper outlier. And because our largest value is 43, that's not above that, so that there's no upper outliers, okay? So we've got to be careful with that. All right, now it actually asked me to put a parallel box plot. So a parallel box plot is when you have 2 on the same number line. So our calculators do that. So what you need to do is go menu, plot properties, and because it's on the X, it's called add an X variable. So if you add an X, now this one I'm going to say, now I want class B. So this is a way to get the 2 on the same number line. So you could copy all of that. So you're going to make sure class B didn't have any outliers. So it had the lowest was high and the highest was 1. Sorry, the lowest was 1 and the highest was 50. So there's how you can get a parallel box plot. This is common in SACs in Year 12 to be doing a parallel box plot. Because then what we would do is we would be comparing the two. So if we look at class A, we would say its median is higher at 27.5 compared to class B, which is 19. We might say that class B, the orange, is more variable because it has a larger IQR than class A. So we could say that. And then we might comment on the shape. To me, this top one looks like this side, the one on the left, is a little bit bigger. So I'm going to say that it is probably negative skewed, where this one looks pretty symmetric. So, and that's how we compare. All right, so we've been comparing, and we will do that a little bit tomorrow. So here is, I want you to now try and put in this data, construct a box plot for the number of hours 33 students spent on a project. So let's go do that.